Hi guys, welcome to Aisha.Academy, and in today's video we're going through functions. So when it comes to functions, they basically take a set of numbers and change them into another set of numbers based on a set rule that they are written as. So they are written as f(x). Okay, so that's how functions are written as. So examples of this. So for instance, you have your input, which is your x, and your output, which is your f of x. So think of it like it's kind of going through a machine. So you got your x going through the machine, and it comes out as f of x, or it comes out as y, okay? So y you may be familiar with, but we use f of x more with functions. But just know the two are interchangeable. So for instance, if you have 2x plus 1, and I input 4 into the machine, my answer would come out as the 2 times the 4 plus the 1, which would leave you with an answer of 9. So composite functions are slightly different. This is where functions are used in the input of another function. So I'll explain what that means in an example. So for instance, we know that f of x generically is like our output function. So sometimes you may see other functions written as g of x as well in exam questions. So in this example, I've got f of x is equal to 3x plus 2, and my g of x is equal to 1 over x. So now if we made a composite function of where f(g(x), think about how g is in the inside of the x, which means we're basically going to input the g of x into the f of x. So it's whatever's on the inside you're putting into whatever's on the outside. So that's going to change the function into 3. So rather than 3x, it's going to be 3 times 1 over x, because the x is basically being substituted by g of x, because it's on the inside of the composite function, plus 2. So that's how that works. Whereas with your inverse functions, this is basically the inverse of the function in reverse order. And it's not written as f of x this time, it's written as f to the power of minus 1 x, because it's inverse, okay? So we love examples to represent things. So an example of an inverse function. So for instance, if we have f of x, and this function, let's say it's equal to 2x minus 3. What we're going to do is we're going to swap f of x with y. And remember I mentioned before that f of x is the same as y. So sometimes students may find it easier to write y is equal to 2x minus 3 and then swap them. So by swapping them, it's going to change into x is equal to 2y minus 3. All we did was swap the letters around. Now that we swapped the x's and the y's, we're going to rearrange the equation to make y the subject. So that's going to be x plus 3 is equal to 2y, and x plus 3 over 2 is equal to y. And now that we've rearranged it to make y the subject, we can now swap the y with the f to the power of minus 1x. And so your final answer is just going to be inverse f of x is equal to x plus 3 over 2. So heading on into some practice questions. Example 1. So in this example, we've got f and then our x value is minus 5. So we just need to work it out. So we're going to substitute the x in the formula with minus 5. So it's going to end up being 2 over minus 5 squared. And that would leave us with an answer of 2 over 25. And we can't simplify that, so that's that. Now we've got a composite function of fg1. So what we're going to do is first of all work out the composite formula, the new one. So remember, as I said, the inside letter goes into the outside letter, right? It's like the inside letter is the baby and the mother's the outside baby, a letter. So it's going to be 2, rather than 2 over x squared, it's going to be 2 over 4x cubed. Because remember, the 4x cubed is the g of x. And the g of x is the baby this time. So that's our new formula. So now that we have our new formula, we're going to substitute x as 1, because that's what the question has given us. And that's going to leave us with 2, so that's not going to change. But the 4x cubed is going to end up being 4 multiplied by 1 cubed. And remember, we need to square that whole answer. So that's going to leave us with 2 over 4 squared, which is also written as 2 over 16. We can simplify this by dividing both the top and the bottom by 2, because that's the common number that they share, common multiple. So by doing that, that is going to simplify our answer to 1 over 8, also known as an 8. Example 2. So in this scenario, it basically wants us to express x plus 2 written as ax squared plus bx. So what we now need to do is replace x in the function with x plus 2. So that's going to end up being 3 bracket x plus 2 squared, take away 2 multiplied by x plus 2, and then the minus 8 is not going to change because there's no x next to it in the original function. So now we need to simplify all of this. So the 3 multiplied by x plus 2 squared is essentially going to be kind of like your factorizing quadratics. So it's the same as writing it as this. X plus 2 multiplied by x plus 2 times the 3. Your 2 multiplied by x plus 2, we're just going to keep it the same for now, and your minus 8 still is going to remain unchanged. So now that we have these factorizing quadratics of the brackets, we now need to expand. So expanding this would leave you with x squared plus 4 plus 2x and plus another 2x. Then you've got minus 2x and you've got minus 4. And take that away from 8. So we've got 3x squared plus 12 plus 6x plus 6x again, take away from the 2x, take away the 4, and take away the 8. That's going to leave you with 3x squared plus 10x, and that's your final answer. because remember that the minus 4 and the minus 8 is going to give you minus 12. Add that to the 12 and that's equal to 0. So that's why that's cancelled out. And then you've just literally got the final answer of 3x squared plus 10x. And I hope that's useful, guys. Thanks for watching.